Hi, my name is Caylee and I am putting together a manufacturing facility to make affordable titanium suppressors. This is episode 2 where I'm putting together this laser and figuring out how to use it. I'm going to laser some stuff, see how it works, and have a good time. But first, why do I need a laser? Well, I have been engraving my prototypes here on my multi-axis CNC lathe, which is very effective at making a beautiful engraving. However, it takes forever. It took like 20 minutes just to do this one engraving. I can't have that happen. This machine needs to be running parts 24/7. I need to clear it up. So to do that, I bought a laser, which is a 60-watt ytterbium pulsed fiber laser. It's a MOPA laser, which means it has extreme precision over the pulses. I'm pretty sure I could do color engraving. It's going to be really neat. I have to figure it out though. First things first, how much did I pay for it, and why did I go with this company? If you go on any of the fiber laser forums, you will run into a lady named Bella Wang. Chinese lady, super sweet. And if you ask her pretty much any question about laser engraving, she will help you. Even if you're not a customer of hers, she will help you. So I was talking to her about what I need for my situation, and she was telling me about probably 60 watts. You probably want MOPA if you're doing titanium or stainless steel. I was like, cool. Can you just send me over a quote for what you got? And she did. She sent me over a quote for $5,140 for a 60-watt fiber laser. In reality, there's a million different import laser engravers, and I felt comfortable going with this company because just like my lathe, the people working at this business are extremely professional and they're super happy to help. Like if you have any problems, I just text Bella and she's like, oh, yep, you just got to do this. So I have no qualms working with this Chinese company. They are amazing. So yeah, we just got to read the documentation and put it together. This has been sitting here for like a month and a half. So first things first, find the documentation. USB, is that open though? Oh, USB drive. Plugging in random USBs from China. Oh, let's see. Oh, look at that. Documentation. This is perfect. There's a little diagram for everything. What'd I say? They got their shit figured out. If you don't mind, I'm just going to put on an audiobook and do it. Okay, we're pretty much together. I've got things plugged in that need to be plugged in. But before I go any further, I really need to turn on Lightburn, which is the software I'm going to be using. There is a cheaper software, I think it's called EasyCAD, but everybody says it's shit and just to buy Lightburn. So I'm going with Lightburn. I'm just going to plug it in and see if that sees this, or see if this sees that. I don't own chairs, so. that made noise. How do I turn this on? Is there an on? I don't think there's an on button, it's just on. The laser came with a USB stick and it had all the configuration files on there, so hopefully I could just stick it on there.
In this video, we will cover some of the basic design tools within Lightburn.
You know, I don't know what I'm doing here. I'm gonna put on laser safety glasses on top of my regular glasses. I'm gonna read some documentation real quick and then come back once I know what the fuck I'm doing. Okay, turns out I have calibrating laser beams in here, but I don't have automatic Z height. So it's just motorized. I mean, it's a convenience, but it's not like super cool. It's whatever, it's fine. So I just line up the 3 dots. And then, in theory, I should project my screen, frame, I'll do bounds, start. Oh, shit! Well, that just... A good thing I have my glasses on. That just lasered that. Wow. I'm curious if I could make that deeper. I'm gonna go to 50% power, see what that does. I'm gonna go to pass count 1, and then fill. So now I should do a scanning laser and fill that in. Okay, I'm gonna do frame, bounds. It should just go. Huh? It's working. I kind of want to stick my hand in there. It's just so tempting. I mean, that's a laser. Well, I've been messing around with Lightburn for about half an hour, just kind of checking out some things on this laser. It works fine. It's surprisingly simple. There's nothing you really set up. You kind of it just works. It's been calibrated from the factory. Kind of boring, actually. Like with my CNC lathe, I spent days setting that fucker up. But this is just, I mean, it just runs. The only thing though, actually programming it, getting better with Lightburn, I think that is the learning curve here. I spent about 15 minutes learning some settings for this, and I'm gonna do one final test, and that's to see if I could, I think this is 0.5 millimeter, if I could engrave this with a black color and then cut this out. You can kind of see there. Okay, let's turn on framing. Okay. And then I'm just gonna click play. Ooh, what is it doing? What the fuck is it doing? Did I make that too small? I'm gonna shut up and just let it run. Oh, what's it doing? What the fuck? It's not engraving shit. Is it even cutting? It's not even... Ooh! That's weird. I could feel it. It's like warm. Is it gonna... Oh, fuck! Yeah, okay. Well, that was 30% power versus 100% power. I sorta. I'm gonna run that again. I should probably cut out. I don't know. I guess I could. Ooh. Yeah. Okay, that's. I don't know. Oh, should I stop this? What if it cuts through? What if it? Will it cut my table? I don't think so. Okay, I'm just gonna assume that cut through. That's a lot of passes. Obviously, I have a lot of settings to look at this. Okay, look at that. That to me looks like a cut piece of titanium, and it's really, really fucking hot. There's no heat discoloring on the back, which is a good sign, but that is hot. See, I think that's why there's the wobble function. I think the line is supposed to cut kind of zigzag to make the kerf thicker. See, that's cut through. I guess it wasn't falling out because the kerf was just way too tiny. That cut fine. That is really clean. Wow. That's pretty good for having zero experience on a laser ever. I'm happy with that. Okay, it's been a few days. I've been messing around with settings on the laser. I have two settings that I really need for the business. Here I have a colorful surface level laser marking. You see I was doing all these things here. These are smooth. They have a nice color to them. This is going to be my logo. And then for NFA requirements, I need to have, I think, it's a depth of 0.03 of an inch, but you obviously want to go deeper than that. So I'm doing like 0.1 or 0.15 millimeters deep. It's a little bit deeper. These are all etches. Like these are engraved into the material. This took me a long time to kind of get a nice finish on, but that one right there, I don't know if you could see it. That is what I'm going with. It leaves a beautiful, kind of like a textured surface finish. But that's great, except this is flat. Suppressors are made of tubes, so I need to convert all this to tubes, starting with rotary axis. So I'm gonna do a rotary axis. I need to set this up. I just wanted to start out with a flat because it's a lot easier just to iterate when you're on the same plane, because this thing it's a laser, so it's heavily dependent on focus. So it's easy to focus on a flat piece and just test it all day. This is gonna be a lot harder on the tube, but I'm hoping with the things that I know and how to do tests, I could get this dialed in pretty quick. Oh, and one more thing. Okay, the last thing I need to set up is fume removal and a little bit of an air blast. I need to set up an air hose of some kind to gently blow air currents over my engraving. And here's why. You can see on these deep etchings here, this white titanium oxide is building up around the outside. It comes off pretty easily with some Scotch-Brite, but I'd rather minimize that. You could see in spots where I had air gently blowing over it, it reduces that deposit. So I'm just gonna get both of those set up at once, starting with cutting out an adapter for my extraction hose. This machine is not a laser cutter, and I don't know if it's gonna be able to cut this 3mm ABS, but I'm gonna try it. I'm gonna cut out the square, and then I'm gonna make the circle on the laser. Is it gonna catch on fire? Probably, but I'm still gonna try it. Beautiful. Start. That's not doing shit. What the hell? Oh god, it smells like burning. Fuck. Stop. All right, I cranked that bitch up to 100. See how it did. I mean, it made a lot of smoke, so. Oh, look at that. Cut right through into my table. Cool, cool. I'm gonna make a smaller circle. And then I need to set my height again. When you start seeing sparking, that's when it's cut through. I'm gonna go to contour, and then I need my air gun. Where's my air gun? ¿Dónde está el air gun? Air gun on. Start. Oh, shit. Shit. Okay, that didn't work. It moved. You can't tell. I can't see. Oh, boom. All right, let's see how well that cut through. I didn't let it, I should have gone around one more time, but that's not bad for something that is not a cutting laser. All right, it's been a few days since I've been working on this. I'm working on my programming kind of first and foremost, but really dialing in this process is kind of, it's a big priority for me because the laser marking is going on National Firearms Act regulated items. Like, these are federally regulated laser marks that need to be made. So the process has to be consistent. It has to be obvious to what the process is. Like, it has to be simple and easy to use. And it also has to be resistant to damage. Like, I have a powered Z-axis, but I actually unplugged that because I'm making one size part. Like, I'm gonna make a jig to make it easy to focus from one size to the next when I get different size products. But if I left that powered Z-axis on, somebody could easily crash this, and then I would have to redial in my fourth axis, or it's not a fourth axis, it's a rotary axis. I would have to redial in that. I would have to re-level the head. It's just minor things that I want to avoid. It's just engineering processes. That's what I love doing. And that's what I'm doing. And pretty much this is set up how I want it to be mechanically. But there's one thing missing, and that's safety. That little 3-inch exhaust fan, let me show you that. This little 3-inch exhaust fan hooked up to some dryer vent, it's just not cutting it as far as extraction goes. So this filter, it didn't really work. It's a car filter. It's supposed to be under high vacuum. So when I put it on a low pressure fan, it doesn't do shit. So I'm gonna revamp the, God damn, somebody's got a crackle tune. I've also cleared up some areas that were having some light bleed. I cut out some foam, just generally trying to make this a safer process. Okay, not too bad. All right, here's our new filtering process. Marijuana Grow Farm carbon filter, which is like, it's perfect. It uses 4-inch hose. It's an activated carbon filter for low pressure, high volume. I've got a larger, chunkier PC fan style extractor. And then of course, aluminum, like semi-rigid aluminum ducting. The other stuff works fine, but I'm also setting up a dust extractor for another process. So this stuff will come in handy. I don't know, I want things to be durable, and I don't want to have to do it more than once. I want to do this right. I spent close to $1,000 on Amazon in dust extraction hardware for 2 processes, but I mean, that's like, safety is so important, because people feel like shit if they're working for you, and they could tell that you skimped on safety. And I should also care a lot about safety, because it's my own breath that's breathing in this stuff. It's harder to care about it in that sense. I'm just like, if I'm doing it to myself, it's whatever. If I'm doing it to somebody else, that's a problem. So we're gonna do it right. Make this safe for everybody, but still do it on a budget. I skipped a whole bunch of steps. I was just trying to get this done. All right, we got our carbon filter. There's another blower inside here. Let me crank them up, see if we get airflow. I'm gonna stick my head in here. Yeah, I mean, that's probably blowing out the mic, but yeah, it's extremely good airflow. I'm happy with this. I'm gonna wrap up some plastic inside a napkin so I can make some smoke, see if I could smell it. I'm gonna leave this in here smoking, see if I could go smell anything. I can smell a faint bit, but nothing crazy. All right, let me put that out. Okay, check this out. I have a finished workspace. I've got a little 5S area for my whip. It's got its own little spot. I've ordered a little desktop that I could put here. So this is like a nice little safe zone. You basically take your, I've already lost my tubes. I have a tube, oh, it's in the bucket, okay. I've got my tube. I'm just gonna hit frame. That's where it's gonna laser. It's gonna go mer. It's gonna laser. It's gonna go mer. It's gonna laser the logo. And then it's gonna go home. Take out my part. Put it in the bucket. Next part. I'm pretty sure I'm going to do a final polishing step after this, so I don't think... I took some Scotch-Brite to those jaws, so they have softer edges now. Yeah, I don't think it's going to leave marks that the polisher won't take off, so let's just try it. We have a part in there. It kind of works out. It's centered up against the face of the chuck. Works out nice. Now, I'm going to close the... No, I'm going to leave the door open, but I'm going to position the camera so you can see. Let me send it home. It should run. Yeah, okay. I'll just let it do its thing. Tube. There's some built-up stuff on there, so yeah, I'll run it through the polisher real quick. If you're curious, this is my other workstation that is getting dust collection. These are Scotch-Brite wheels. It's a cylindrical, centerless polishing machine. Basically, this wheel turns at a bit of an angle, loops the part through in front of the Scotch-Brite wheel, but it needs. I got to give it the treatment. It needs stuff. Everything just needs to be cleaned and oiled, and anyway, run it through once. All right, so after running it through the polisher, we still have plenty of depth on that engraving. You can't really tell, but it's there. And then the logo still has most of its color. I feel like I need to tweak these settings a bit, but as far as kind of just getting a process going, that is legally meeting all the requirements. I mean, I don't know what to say. That's about what, 40 hours that I've been putting into this. That's this week done. I have a work cell. Like, my lathe is in progress. That is so much bigger of a job to dial in. There's so many parts that need to be made over there. The polishing, the anodizing, they're just kind of up in the air until I really get everything dialed in. But this is dialed in. It has programming. It has even has like a button on my desktop where I just click it and it pops open the program. The programming for the serial number, it seems pretty easy. I haven't done that yet, but I'm just manually entering it now. I'm stoked. This is the first work cell that I have completed to my own satisfaction at Caylee's Cans. Like, that's, everything else is a fucking mess, but this is done. Well, there you go. Thanks for watching me dick around with the laser. Bye.